Welcome, everybody. Thank you again so much for joining us today. Welcome to our fourth webinar series. Thank you for all of those who attended last week, webinar on fears and anxieties. We do hope that you have enjoyed and are enjoying our webinars and are learning from them. And if so, please do not forget to leave us a comment, subscribe, and follow us on social media. As some of you will know, we are AFBE-UK, which is the Association for Black and Minority Ethnic Engineers, and we aim to provide support, create engagement, and promote higher achievement in education and engineering to professionals, the new ones and experienced ones, as well as students. Today, this event I've been waiting for since the very beginning. We do have a fantastic event for you. Dr. Folayan, MBE, will talk to us through the evolution of radio and debunk some of the myths we have been hearing recently. This will be an excellent session, especially considering some of the recent events linked to myths that Dr. Folayan will debunk. I don't want to tell you what myths, but I'm sure you've been listening to the news and heard some attacks that have happened regarding these myths, so it will be very interesting. This session is one of the ones, as I said, that I've been looking forward to, so I cannot wait for it to start. However, just before we start, just to create a little bit of an icebreaker, please, would you type into the chat box, what is the wildest myth you have ever heard? And just to get you started, I'm going to go into something that might be a bit controversial, don't know, but one of the myths that I've heard recently is that the Earth is flat, not round, but flat. If any of you have any other myths, please feel free to type. Nikki, do you have any myth that you've listened to recently?
Oh yeah, I was just telling you about a £20 note. One of the links to coronavirus is the £20 note, and apparently, if you look on the £20 note, you'll see a sign of that looks like the coronavirus, and you'll see a sign that looks like a 5G mast, and then if you add some numbers together, you'll get 666 somehow, and yeah, and so it's all linked. So there you go.
I need to get myself a £20 note just to see, and then throw it away straight away.
Yeah. The message is don't ever have a £20 note. It's bad for your health.
And by the way, I'm taking all the £20 notes. So if you're looking to discard yours, by all means, throw it this way.
So you don't mind the myth behind it.
Yeah, I've heard that one, but I think that was quickly debunked with factual evidence. You know, so there's nothing in there. But if you're scared of your £20 notes, there's only one way to send it: this way.
Okay, noted. I think there's a couple of other comments. Somebody said they heard that alligators live in in New York City subways, or was meant to read sewers. So alligators in the sewers of New York City. That could be true, maybe. Or that drinking chlorine will eliminate coronavirus.
Right, and then I see the disinfectant where it knocks it out in 1 minute. And is there a way we can do something like that by injection inside or almost a cleaning? Because you see it gets on the lungs and it does a tremendous number of the lungs. So it'd be interesting to check that. So that you're going to have to use medical doctors with. But it sounds interesting to me.
Okay, that's one I do not want to try.
Me neither.
Yeah, it will definitely kill us. And that the queen is a cannibal. Okay. Yeah,
that's really funny.
That's for everybody. And somebody's asking, does Igbo cure coronavirus?
That's weed. That's weed.
Ah, okay.
Weed.
I was going to ask, what is Igbo? Yeah, now I know. Okay. Just another one. It says here, the virus was created to destabilize China.
Yeah, that's definitely true, that one.
Yeah. And if drinking alcohol does clear the virus, then hey, I have wine and vodka, so that's going to be my evening sorted. Okay, thank you everybody for participating. So without further ado, I'm introducing you to Dr. Folayan, who's going to take us through this webinar.
Okay, so yeah, welcome everybody, and this is something that actually, funnily enough, we'd planned to do before the corona craziness. I was going to do a talk on evolution of radio, so this has come at a really timely opportunity to talk about the things I'm really passionate about, and the reasons I became an engineer, being television, which hasn't killed me so far, but you just never know, do you? So I have a presentation. I'm gonna go through the presentation really quickly. I am gonna need your involvement as well, so there will be some quizzes and questions for you to get involved in, so it's not just me talking at you. And then I know that there have been some questions submitted, then we'll go through those questions, and obviously then we can then take some additional questions or feedback on the talk. Okay, so yeah, so welcome to this talk on 5Gs of radio, and I thought the first slide it would be good to have include the applications of 5G, which is the Internet of Things, smart farming. And the one that I really kind of thought was cool was the healthcare systems and people doing surgeries across the globe. Autonomous vehicles, yes, it's 5G, but you don't actually need 5G for it. Smart homes and cities, and security and that sort of thing. So those are the applications of 5G. But I'm going to go back to the beginning of what radio waves are, or EM waves, or EMF, or whatever we want to call them. And they're used in our space as a communications medium. So one-to-one communications, you see them, used in films for walkie-talkies, where you hear people say over and out, you speak and then I'll speak, and that sort of thing. It's really key to what the emergency services are able to provide. So from everything from fire to ambulance services and so on and so forth, and something that has become really part of our lives, which is mobile telephony, or so cellular services and that sort of thing. So it's basically a communications medium, because you can't speak to everyone everywhere at the same time. So believe it or not, there was 0G before 1G came. 0G you will find in some of the older vehicles, where they had like a cab radio installed in the radio, where you could make it's essentially a telephone in a car, but they were covered by different radio masts in the locations. They had about 30-meter radius that they would cover. So just to say that mobile communications is relatively new, but it's not as new as we think. It's just been transformed into different sorts of things. And then we had the 1G, which is the picture at the bottom here, with those really heavy style mobile kind of phones that only really wealthy people had. And then in the 90s, 2G came along. And then you had the ones that people don't know about, which are things like the 2.5G and the 2.75G. Some people call it 2.9G. The difference is that we changed from what in our industry we call from circuit switching to packet switching, but you don't need to worry about that. And then we had the 3G, which obviously the main differences between the different generations was that as the generations went, the speed, the download speed, if you ever had a 2G GSM, you'd know the difference between that and what you have as a smartphone, and you can now kind of use your phone to do all sorts of things, from watching movies to downloading stuff and so on and so forth. So the evolution of radio, mobile radio, has really been around a number of things. about around speed, so getting things done quickly, and so making the world more efficient for us, and also around minimizing latency. So before, it will take you maybe 10 minutes or so to download something. Now you can download that in less than a minute. So you'll see that speed is measured in bits per second. So as the generations went along, the bits per second that you could kind of see continue to increase. And believe it or not, people are talking about 5G at the moment, but there is 6G already kind of being worked upon. And 6G is going to be even faster than 5G. Now, the important thing to take away from this is that as you increase from 3G to 4G to 5G, you increase the number of cells. So you'll see more antennas, you'll see more mobile towers, which is obviously scary for people and thinking what's actually going on, and that's one of the things that people are talking about a lot. But I'll go into a bit more detail later about 5G in particular, because that's the issue at hand. So 5G is broken down into a number of bands. You have low band, mid band, and millimetre wave band, which is greater than 24 gigahertz. But I'll talk a bit more about that in a bit. So in terms of the applications, this kind of gives you the applications, just in case you didn't know. If you ever had a 2G phone, you'd know that it was SMS, and even the way the phones were to type, the keypads were really, really difficult to use. You'd spend time just typing quite simple messages to what you have today with your touch screen and so on and so forth. Again, just showing the evolution is because of the need for efficiency in our world. Things are fast-paced, things are going really quickly, and we've got to catch up with things and the times. And so it is really about making, as a radio engineer, I'll say it's really about making the world a better, more efficient place to live in. And we're so used to it now that we see most of our communications as just part of the things that happen, and we don't really question it at all. In terms of 5G, what are the benefits of 5G? So 5G is broken down into three kind of use cases. One being fast mobile, so the EMBB, so fast mobile communications, fast speeds to download videos, and so on and so forth. The second part is about latency, so ultra reliable latency sort of thing. What latency means in this sort of space is delay. So how long it takes for you to, you're late. Okay, let's use the word that maybe most people know about being the delay before you receive something. So that's what latency is about. And the most fascinating part of this 5G technology is that we can now use it for machine to machine sort of communication. So this is where the Internet of Things comes about, where things are communicating together. This is where you have smart sensors in farms. So if you Google something like smart farming, you will find that it talks a lot about how you can understand the ground, you can understand the topology of the area before you plant, you can understand how your crops are growing by just having a few sensors on your farm. So they're really use cases that help us to further the way that we do things together and to bring us together as a connected society. Going back to the physics behind it, I've included this because I think it's really important that we understand what radio waves are. Radio waves are made of electrical and magnetic a field. So you have in here you have a simple conductor, and you have the electrons that go through it. Don't worry if you don't understand what I'm talking about. It doesn't really matter. It's just kind of trying to break it down in that sort of way. And so the electromagnetic wave is made up of two fields, an electric field which goes through the conductor, and a magnetic field which is perpendicular to that conductor. Now, the most important thing on this slide is what this means. So this means this is related to the speed of light, the EM waves and the speed of light. I think most people understand the speed of light, and people have accepted that light has a particular speed. So every frequency is calculated based on the speed of light. So C here being the speed of light, the wavelength, which is what people are talking about, and frequency, which is what a lot of people are talking about, is made up of, so the wavelength and the frequency makes up the speed of light. So essentially, if you have a longer wavelength, the wavelength will be based on the speed of light divided by the frequency. Just hold that thought. What is radiation? Radiation, essentially, everyone, at the moment, everyone's talking about radiation, but radiation is everywhere. Obviously, if you've had to have an X-ray, that's radiation. If you've been outside and the sun was shining, that's radiation. And even human beings, we produce radiation from heat. So we radiate heat. There's obviously RF radiation, which has to do with transfer of energy by radio waves, but there are two types of radiation, and this is really important as a basis to understand what I'm trying to say. Now, there's the ionizing radiation, which is a high energy radiation, which includes things like X-rays and so on. And that's why you have a lot of precautions when you go into hospital and they need to do some X-rays as well. And those are the EM waves, or the electromagnetic waves, that carry enough energy to ionize or remove electrons from an atom. Yeah. Essentially, what you need to know about ionizing radiation is that they can damage the DNA inside of cells. Yeah, and that could cause cancer. So that's one you need to be careful of. The other side of things is the non-ionizing radiation, which doesn't have sufficient. It's basically it's on the low energy spectrum. Yeah, low energy spectrum. Yeah, and it doesn't break down any chemical bonds, and it doesn't remove any electrons. Yeah, so that's the basis of the talk, really, just to understand one. Not all radiation can cause damage, but some can. Now, I got this yesterday. I was really excited this morning when I saw that Ofcom had released this, and it essentially explains what I'm talking about in terms of non-ionizing radiation, ionizing radiation. At this end, you'll see that there's ionizing radiation, and this end, you'll see there's non-ionizing radiation. So non-ionizing radiation literally starts from your TV all the way to your Wi-Fi, to all the mobile comms you have, and actually it does include the 5G band as well, yeah, and 5 gigahertz Wi-Fi. So in some areas you have Wi-Fi 2.4 gigahertz, and the other sometimes you have it at 5 gigahertz. Now, I think what people are most worried about at the moment is the future of 5G, which kind of starts to move closer to the ionizing radiation. Remember, the visible light is at this level, and so on and so forth. So I think people worried about this space the most. They don't know that's what they're worried about, but a lot of the talks that I've listened to and a lot of the videos I've seen talks about the millimeter wave, which we'll talk about in a bit. So just to break this up a little bit, I'd like to ask, and Shayla, I'll need your help to kind of see the responses for this one. Can you think of sources of radiation around you, and can you just put some answers in the chat box?
Microwave oven, Sherman has said. Sunil as well, microwave oven.
Fabulous.
Microwave, I think a lot of people thought about it. Everything. Okay. The sun.
Okay.
Mobile phones. Sound waves from a speaker.
Fabulous.
Sun, radiator, TV, laptops. Wi-Fi, LED lights, yes. Trump's standing room. Love that. Bluetooth, antennas, mobile phone transmitter, Brazil nuts. I'm not sure I understand that one, but okay. Sky Q box.
Okay.
Heaters.
Okay. No, so I think people get the general idea of this. But there is something called the extremely low frequency radiation. So that includes things like power lines, that includes things like household wiring. So if you've got a socket in your house, you've got radiation to worry about there. If you've got a fridge, you may want to throw it out because it does have some radiation as well. And you mentioned the other things, even baby monitors or electric blankets, for those that have used them before. those all have connection with extremely low frequency radiation. So we shouldn't be, my message here is we shouldn't be afraid of the word radiation. I think what we should be concerned about, or maybe not even, is what type of radiation is it, and how does it impact our lives, and is there anything to worry about? So sources of radiation we talked about now. Lots of people have said the sun, the earth, infrared and RF sort of thing, outer space. You've also got the typical things like Wi-Fi and Bluetooth and welding machines. And if you've actually been to an airport and you've gone through the scanner, yeah, so that's a source of radiation as well. So something to think about. Something to think about apart from mobile phones. Most of the time we associate radiation with mobile phones, but there's so many other sources. So how does radiation, how does EM radiation, how much are we exposed to, and what's the impact of the exposure? So the first three things that you've got to think about is the strength of the electromagnetic field, which is to do with energy, so volts per meter. And then you've got to think of how close, the proximity from the source of the field, and the length of time. So the highest exposure occurs when a person is very close to the source and stays there for a long period. So walking past the tower does not make you, it's not enough time for you to be exposed to enough radiation to cause you issues. I think the more challenging bits is people that have their mobile phones kind of next to them watching Netflix, fall asleep and stuff like that. So there are things that we can do as just to bear in mind, when we're thinking about radiation, when we're worried about stuff like that, to make ourselves feel a bit safer. I'm not saying that these things have an impact ultimately. What I'm saying is just the heat generated from the thermal effects of having these devices next to us isn't a particularly positive thing. You will find that if you've been using your mobile phone for hours, you'll probably end up with a really bad head. so that's due to the thermal effect of actually just using any equipment for a long time, and it's the heat that it generates. Now, I want to explain this because I think it's really important, the absorption and penetration, what it means. So the first thing to note is that the people saying human beings absorb EM waves or radio waves are not lying. Human beings and human bodies do absorb radio waves. And this is actually defined by what we call the specific absorption rate. So watts, which is a measurement of power per kilogram. Now, most TVs will have much less than a watt per kilogram of absorption. But what's happened is that there are lots of stringent standards. That means that the limit of allowable specific absorption rate is 4 watts per kilogram, and you can check this on your mobile phone actually. So if you have a mobile phone, you can look for the SAR value to determine how much is allowable via that device. So there are lots of organizations actually watching how much absorption that we're exposed to. The other one is penetration. So the penetration is about how radio waves travel. And as you decrease frequency, basically from the first formula I said, which was C equals to wavelength by multiplied by frequency, as you increase the frequency, you have a longer wavelength. As you increase the frequency, you have a shorter wavelength. And as you increase as you increase the frequency, you have a shorter wavelength, and as you decrease the frequency, you have a longer wavelength. And that means that sometimes as you increase the wavelength, so to the millimeter waves and so on, you won't have, it decreases the penetration. So it's the wave is so short, so tiny, so in millimeters, that it can't penetrate buildings. And this is partly why you'll find with 5G in different locations, you might have more cells, as I call them, or more towers than you normally have. So there are two types of frequencies that we usually kind of concern ourselves with. One is the microwave, which is the 300 megahertz to 30 megahertz, which is from things like your television, mobile, and so on. And then you have the millimeter, which is from 30 gigahertz. But these days, considering 24 gigahertz as part of it, is common. So what's important to note is these are the wavelengths. So you have 1 meter. So one wave is 1 meter, and 30 gigahertz, 1 millimeter. And for those higher frequencies, you have 1 millimeter, 10 millimeters. And if you have a ruler, or you realize how small these waves are. And the applications are a millimeter wave imaging. And if you've been to an airport and you've gone through checking, you've probably gone through a millimeter wave scanner. If you had a CT scan, you've gone through a millimeter wave equipment. So just to bear in mind, millimeter wave isn't a new concept, and isn't a new. I think what's new is the use of it for mobile communications. It isn't new particularly. Now, for the UK, these are the frequencies that we are using for 5G. You'll note that some of these frequencies are quite familiar. So the 900 megahertz is what we currently use for 2G, and it's going to be refarmed for 5G. So refarming means using an old frequency to allocate it to a new technology. You'll also find that this is also kind of used for 2G. And obviously now we're refarming it for 5G. One of the reasons is because we don't want to go, it's going to cost us a lot of money to install so many new towers to cover 5G. And then the highest, frequencies you have are about 3600. So the millimeter wave that people are on about and saying is going to cause harm and so on and so forth doesn't even feature at this point. Yeah, so they don't feature at this point. Obviously, there's a kind of intention to use them in the future, but they don't feature at this point. So when people say that they've had issues because they've installed 5G antennas and it's causing them problem, these are frequencies that we've been using since 2G. So it's difficult to kind of say, oh, now that we have 5G, it's because of the frequencies and so on and so forth. It doesn't follow. There's no correlation between the 5G that we have today and any, if there was going to be a problem, we would have had Corona since the 1990s. That is my view. And so essentially, just to kind of explain the spectrum again, it's about frequencies. One is that people can't just install things wherever and whenever they like, because you need to obtain permission from organizations like Ofcom, and then even when it's license exempt, like the Wi-Fi frequencies, it's actually kind of the rules that you have to follow. So just going to the myths quickly, I thought I'd share a few myths before we go into questions. So, there's this thing that people say, oh, there are no risks associated with 5G, and, am I just being silly about being worried about 5G? And what I'd like to say is that, no, you're not being silly. There are effects. I mean, there's two sides of the story. There are scientists that have done experiments to show that EMF has some effects on people and humans and so on and so forth. The challenge that we have with those people that have shown it is that in science and in engineering, experiments have to be repeatable. So if you have a small sample and it's shown that it had this particular effect, then someone else has to be able to repeat the same experiment, carry it out exactly the way that you've done, and verify that that's the case. That's not been the case. What has tended to happen is that people have done studies on mice and so on and so forth, but they've done them in isolation of any other component, and they've said, this is causing cancer, or they've done them not in isolation, they've added additional stimuli. And so you can't determine whether it's the additional things that they've added that has caused the effects, or it's just the radio waves. And so this is an argument that is going on, and I'm not going to sit here and say to people, don't worry about it. Everything in life has major risk. If you're crossing the street, it's a risk. You could, you could die. You could get hit by a bus. Hopefully not, but you could. So it's not actually as silly as sometimes we try to make it sound. The fact is, at the moment, what we know from the science perspective is that there are no more significant risks than any other technology that is currently in place, especially because at the moment we're not even using the millimeter wave length that people are particularly worried about. So I have a quiz for you. Where was the first 5G deployed?
So we have China, Wuhan province, South Korea, China. Some people think South Korea, some people think Japan, UK, not Nigeria. So I think the majority of the answers is between China and South Korea. Some people think Hawaii, which is not even in the answers, but okay.
Hawaii?
Okay, yeah.
Okay, that's interesting. So the first, it's South Korea. So the first deployment of 5G, the US will argue that it wasn't a real deployment because it was just in a small location, which is fair. But the first deployment of commercial 5G was in South Korea. I think they had around 1 million subscribers within a really short space of time, and after that was Japan. So China doesn't even feature at this point. So it's South Korea, Japan, and guess where else next? It was the Philippines. So when people talk about China being the source of 5G and the corona, that's another thing that we need to think about. It's not necessarily true. So another myth that people have had and people talk about is, oh gosh, it's everywhere. You know, this thing, I can feel it. You know, I feel it physically. I feel hot, and so on and so forth. And based on the fact that, you know, you're located, the distance that you are away from the towers, and these towers are usually fenced areas, and then obviously if you're just feeling it now, and you didn't feel it when the 4G technology was there, which in most cases they're just adding bits and pieces, upgrading to get the 5G, then I would question how you all of a sudden feel it now more so than any other time. So, you know, we can discuss that a bit more later, but you know, it's not the case that you have now. I think what you should be worried about, and maybe not worried about, but what you should be thinking about is if you're feeling the heat, maybe what are the things around your environment that create heat? What are the things that give off heat based on radiation? The third one is about 5G, 5 gigahertz being the same as 5G. It is not the same as 5G. 5 gigahertz is to do with the second frequency that can be used for Wi-Fi, and that's different from 5G. So 5G technology works at millimeter wave. I think I've said this. There's a low band, a mid band, and a high band, so millimeter wave. So it's spreading corona. There is no link that has been shown so far that it is spreading corona. Corona is a virus. I do have someone that understands a bit more about virus in my family, and based on the discussions we had, it's difficult to justify that 5G technology working at currently, not even at millimeter wave, but at our 2G, 3G, and 4G bands is causing COVID-19. Now, here are these are the allocated frequencies around the world. You will find that China actually sits at 2.5 gigahertz, which is just above 2.4 gigahertz with their 5G technology. And then you will look at all the way to, you know, Iran and Turkey. And I don't know if anyone has looked at this, but these are the countries that have had the most significant, COVID has had the most significant impact on. And you'll find that none of these countries are working at, they've auctioned, I know that, I can't remember which country, I think it was South Korea have auctioned a millimeter wave band at 28 gigahertz, but you'll find that some of these places don't even have don't even have 5G at all. So Iran, there's no 5G, and the effect of COVID has been significant, and Turkey doesn't have 5G. So it's difficult to, just based on this, to say that 5G is causing corona. Another one is that the 5G base station is going to kill us, and I've seen birds falling from the sky and trees withering away. I think there's lots of ways that we can explain those things that have nothing to do with the 5G towers. One of which is that most 5G towers are fenced, and they're an obstruction to a bird and a thing, and they're flying across. And they're hardly kind of open areas where these things happen. Birds falling from the sky and trees withering away needs a bit more investigation, especially when half the time the antennas that they're calling 5G antennas are 2G and 3G antennas, the ones I've seen in the videos anyway. So another question for yourselves is, when and what was the first ever all 5G smartphone released? We try and maybe answer in the chat box again.
2018. First,
Okay.
Huawei, I cannot say that properly. Samsung
Yeah.
S20 last year. Huawei 2018, 2019.
Okay. So the person that said none is actually closer to the truth, because the first ever all 5G smartphone was released in April this year. so there goes that there are 5G phones, and I said all 5G on purpose because they're 5G. They're phones that can be adapted to work at 5G, but an all 5G smartphone was only very recently released. So I've talked about the applications. Again, I'm not going to talk about them further. It is the fastest growing technology, so I can understand that people trying to link it to, as I said, people trying to link it to what's going on. It's a visible symbol of change, and people are concerned, and rightly so. They're concerned about the health, and some people even believe there have been no investigations on the health impact of these technologies, which isn't true. There are lots of organizations looking at it. It's in 40 countries, and I think it will carry on because of the reasons and because of the use of it. I think it will make the world, from my perspective anyway, a much better place in terms of doing things more efficiently, like particularly the medical impact of being able to do a surgery without being physically there. It is significant. So I've overrun my time by at least 5 minutes, but I've come to the end of my presentation, and open for questions now. Thank you.
Thank you so much, Nikkei. I thought it was very good and very enlightening, understanding the technology behind 5G and understanding no links behind the myths that are out there. So we're going to open the floor to questions, but before we let you ask your questions, we had a few questions sent to us earlier on. So we're going to go through those. And there's a few questions that have been coming on the chat that I'm going to go through, and then I'll open the floor for questions, obviously time allowing. So the first question that we have is from David Pate, and he's asking us, what is the main benefit of 5G? Increased bandwidth or better quality of service?
It's not one or the other. Quality of service. Well, if we talk about quality of service, then we talk about things like latencies, obviously. So, yes, it is better from that perspective. It's lower latency. But more importantly, it's the number of assets that you can connect to a 5G network that you couldn't with the predecessors. That makes a difference. The number of assets that you can link together. It just makes things more efficient. It's a more efficient use of the spectrum as well. So those would be the reasons why 5G actually kind of, let's take it out of the mobile communication phone perspective, which is kind of better speed and blah blah, and some people don't care about that. It's how you are going to connect different devices and how you're going to use it to make the world a more efficient space.
So the connection with Internet of Things is one of the main
Yes.
benefits. Yeah.
Yes.
Okay. Thank you, Nikki. So the next question that we have is from Mr. Liu. He says, from the news, the range of 5G signal conflicts with the frequencies that the meteorological satellites are in use. So how could the 5G infrastructure operate with minimum negative influence to other services?
So the first thing to note is what I said previously, that currently most of the 5G systems installed are not at those. So I think the weather forecasts and so on at about 24 gigahertz, between 24 gigahertz and I think 26 gigahertz, somewhere between that. And at the moment, what's happening is that we're working at much lower frequencies. So we're working at the top frequencies at 3.4 gigahertz. So it doesn't even feature. It is a concern because obviously and this will happen when we start to use millimeter wave for whatever reasons in small spaces for 5G, then it is a valid concern. But I feel that those will only be used in dense areas. So those will only be used in like really small areas. And obviously interference always happens. Even at the moment, if you're on a train, and I work in the train in the rail industry, and you go past some communities, there's your communication, your radio communication on the train could interfere with your signal if you live close by. So interference is something that in the industry we have to continue to look at and we have to continue to deal with. But yeah, it's a valid point. Not at the moment to worry about. We have a few years to go before we start worrying about that. So the weather people can sit pretty
Relax.
for now. Yeah.
Okay. Do you have any idea? Could you tell us? And this is a question from me. Based on the previous question, when will this millimeter wave come into place for 5G? Is it in the near future, or are we talking like 10 years in the future or something like that?
I don't know that it's in the 10 years. I think it, because of the way technology moves, I think it is less than 10 years, definitely, because they're already auctioning millimeter wave, and I think that's what people are concerned about, really. They're already auctioning it, but the issue is kind of auctioning it out and finding the use cases for it. That's going to take a bit of time. And so before you adopt a technology, you need to understand that and what your use cases are. And you need to obviously show that it has a minimal impact on the other services going on. So it might be 10 years, but I think the rate of technology means that we don't know. And because obviously people are already looking at 6G, which is even, it's definitely in the millimeter wave band. So things to worry, there are lots of things to worry about. It's not valid to worry about these things.
Okay, thank you. I think you went into one of the questions that I will ask in if we still have any time, but we have plenty of questions to go through. Another question is, a conspiracy theory takes advantage of lack of evidence to create logical argument to support their claims. That's why it's often very convincing to many people, but also on the other hand, the proponent, scientists, usually have an explanation to that argument. So my question is, in the lack of evidence, and given that we have seen in history where something emerged, scientists didn't know, but they thought they knew, or something they completely didn't know they know about, how does one know what to believe?
I think you've got to go with the facts as you have them today. You've got to go with the evidence as you have them today. What I've tried to pull together in my presentation is I used to literally live in a chamber, and then quote chamber, and I'm still alive. So that's number one proof that you won't die from these things. But no, on a serious note, you've got to you've got to look at the evidence for yourself. There will always be conspiracy theories. I saw one that said in 1991 we had 3G, and that's at the same time we had swine flu. And I said, well, in 1991 also there was a telescope that needed replacing, so it's probably the telescope that's caused the swine flu. So you can literally link anything that you, as I said, the £20 note, you can link it to whatever you like. The most important thing is understanding that even in the science world there will be different views, investigating, and more importantly doing what you can to keep safe. I think the major issue that I have with 5G at the moment is actually the security aspects. For example, the UK working alongside Huawei, and there are concerns that they're spying on us and so on and so forth. So the more you connect your IoT, the more you make your home smart, the more people. Already we know that Google records most of the things that we say. So having someone installing all this equipment, many countries can't do anything about it because they've been in bed with Huawei for a long time, including the UK. So whatever it is we do now makes very little difference. Most of the components of our different radio frequencies are Huawei components. So yeah, it's just important to protect yourself as much as you want and know what the facts are, investigate the facts for yourself rather than videos from people that don't even know what a radio wave means.
Yep, I completely agree with that. Thank you for that. And I guess one topic to discuss in the security aspects, as you mentioned, because that is something that we all need to be aware of. And I won't say scared because we all already, we all provide all of our information to everybody who wants to see it. So, but yeah, it's definitely a topic to discuss. All right, moving on to another question. Aside from the unfortunate and illogical link to COVID-19, can you say unequivocally that 5G is safe under all circumstances? And at what point would we be able to push back on technological but harmful innovations? Is there a platform? Sorry, this is a long question. Is there a platform for it?
Well, there are a number of bodies that kind of push for it. One is the I think it was non-ionizing radiation committee that kind of sets the limits and so on these things. So there are organizations specifically looking at these sorts of things. I was personally, I worked in a lab in Sheffield where my colleague was working on looking at the links between cancer and radio frequency waves. So there's active work going on, not just from the medical side of things, but from also the engineering side of things, looking at the possible non-thermal effects of these things. And they're over 30 years, there've been a lot of papers around this topic, and so far, the safety guards and the levels of radiation have been in such a way that we've tried to minimize the harmful effects of these sorts of things. So it's just important to know that this isn't no one should be able to say anything's completely risk-free, because that would be a lie. But in terms of providing mitigations to minimize the risk, that's currently in place. And just looking at, next time you get a new mobile phone, take your time, look at, it usually comes with a manual, take your time, look at those values, put those values on the internet, see what you get. That will give you some comfort, hopefully.
Well, hopefully. I think we all have to do that, because I personally never look at the manual.
I do, but okay.
You're good. So the next question is one of the questions from the chat, and he asks, I understand that Ofcom is the main stakeholder behind rolling out our 5G. If this company is so invested in this technology, is the scientific content provided by the specific company reliable?
Now, Ofcom doesn't really run as a company. Ofcom is a regulator. So their job is very different from a company. They don't make, they've done a report, which, I've shared in the I will share in the references. I think I have a references page here for you to go and do your investigation and so on and so forth. So Ofcom in itself is not, they don't gain anything by, they don't have any particular gain by saying this works or this doesn't work. The recent report shows that 5G is 0.039% below the limit that they can get to for radiation. So in the UK, so they've done their independent investigation, and they've shown this. They don't gain anything by saying, if it was Vodafone, or no disrespect to Vodafone, but if it was Vodafone or Everything Everywhere or MTN or whatever that was telling us this, then we should be really suspicious. And they've all tried to have statements to say that this is not harmful. But I think we can hope that Ofcom, based on the measurements, and they include the measurements in the report, are telling us what things are actually out there without any bias, or limited bias at least.
Okay, thank you. We have quite a few questions to go through, so apologies if we don't go through all of them. And I know that somebody wants to make a quick contribution, which I'll let that happen at the very end, just before we go. The next question would be, is there a link between radiation and virus mutations?
I don't believe there is any scientific, I personally have not seen any scientific papers, and I've done a bit of research, and I do have, as I said, I do have someone that knows a bit more about this topic in my family, so I have asked a few questions, and I don't see that there's a link between viruses and radiation. Even what's his name? I think it's called Michael Paul. He's written a number of papers, and he's kind of the champion, this big champion of use of stopping us using technology. I mean, radio devices and so on. His view is that the EM waves kind of activate something called VGGC in our brains, and that causes cancer, and that causes all sorts of things. So even that's not a thing that he could. I've read a few of his stuff, and I've seen very little evidence of test cases that show that there is any kind of connection in that sort of way.
Okay. That's good to know. That is good to know.
Yeah, and he's included in my references just in case other people want to check as well.
Which will be available when we release the video on YouTube. Yes. The next question, which is actually a question I had, but I didn't ask, I promise. The railway used 2G for GSMR phone network. When refarming, can the old mast be repurposed for 5G, or is it completely new infrastructure required?
Required for the railway, or required for 5G?
For 5G.
So they, you can repurpose equipment. Obviously, for 5G, you'll need to upgrade the equipment in some shape or form, because bearing in mind, it's not just the towers. There's a digital signal processing that has to happen. So you can repurpose the existing, because people, 2G is, 2G is just obsolete now, because that's the way technology works. So a lot of the mobile providers are refarming those frequencies for other uses, and one of the uses is GSMR, which is 2G for railways. So yes, you can do that. Obviously, for 5G, if you're going to use 5G, then you'll need to upgrade the equipment. So things like the base stations, or whatever you choose to call them these days, like radio heads and so on.
Okay, it does answer my question. I hope it answers whoever put the question forward too. So we then have a question that I'll skip for now, because I think it'll be a little bit more detailed. But just so that you know, Nikki will then look at these questions and in due time try to answer them. So don't worry if you don't get your answer now. Eventually you get them. The next one was, will millimeter bands be used primarily for IoT or voice?
You don't need them for voice. You won't need them for voice. I think we have got voice to a T now. Yeah, you know, voice was the start of the 2G. We had voice. We don't need IoT. I mean, we don't need millimeter for voice. What we need it for is the machine learning, and the other bits of the use cases for 5G. So it's unlikely that you'd be doing that. And besides, it doesn't carry. It's 1 millimeter to 10 millimeters. Just think about 1 millimeter to 10 millimeters. How much can you how much can you carry in that? So it's unlikely to be used for voice. Yes.
Okay, makes perfect sense. The next one is, will the download speeds on 5G be better than fiber broadband?
Yes. That's a simple one.
I think you
Much
started with
better.
that.
Yeah. So your Netflix is on flick now, or your whatever it is you like to watch, or your YouTube is, well, your YouTube is already on flick, but you know, the time that you take to download a movie, where you what do they say? What do these young people say? Netflix and chill. uh, which I
That'll be a
only
lot
heard a
easier
few.
with that.
Yeah, exactly. Yes.
Right. I'll go through one more question, and then I'll let the contribution be made, and then we'll finish. Um, so can you talk around 5G fleet management impact and advantages? So this is the question that I said we could ask later, but I just seen that it's been asked again. So I don't know if you can do it briefly, and then any further detail can be provided later.
In terms of fleet management, so that's not my area of expertise, but I will say that at the moment, there's still a lot of physical manual um, requirements when you talk about fleet management and stuff like that. What the 5G would allow you to do, which is what it does for other things, is that it will allow you to be able to do, again, provide efficiencies that you wouldn't have had without 5G, because the different parts of the system can communicate with each other without you having to interfere, without you having to provide some inputs here and there to get things done. So that's what I
Okay,
would say.
thank you. That was short and sweet. Thank you so much for that. So I do believe um, Emmanuel wanted to give a brief contribution. So if you can.
I just wanted to make a quick contribution in the area of the possible side effects that EM radiations could have on the human body or the human cells. Like you rightly pointed out, I mean, there's been a lot of ongoing research just to try to understudy possible effects that EM radiations could have on body cells. And so far, well, as far as I'm aware, yeah, I could be wrong here, there's no concrete evidence to really show the extent to which you can have those effects. I would just point out, which, just like you have already done, there are two frequency ranges for 5G. There's the LTE frequency range, which is below 6 gigahertz, and then there's the millimeter wave range, which is between 6 gigahertz up to about I think 86 gigahertz. For the second range, which is the millimeter range, that's when you start to worry a lot about the side effects it could have on the human body. There is a correlation between frequency and energy from Max Planck equation, E equals HF. So the higher the frequency, the higher the energy of the radiation, which is when we start to talk about ionizing radiation or non-ionizing radiation. Yeah, one of the major concerns surrounding 5G is the potential for it to cause cancer, just like you have earlier on tried to explain. There has been a lot of study to that effect. So there are two basic types of effects that EM radiations could have. There's the stochastic effect, and then there's the deterministic effect. Deterministic effect occurs instantly, and the severity actually increases with the radiation dose. There is a stochastic one which does not occur instantly, so it takes a bit of a time for such effect to start to manifest. There was a study that was carried out following the bombing of Hiroshima and Nagasaki, and a couple of people were followed, in that study. Those who lived around that community, and then they were studied over a period of time, and about 100,000 of those people was studied, and only 2%, died from cancer cancer-related cases over a period of 50 years. Over a period of 50 years, that just points to the fact that given the amount of exposure they had to a high intensity radiation from the bomb blast, it took a very long time, 50 years, for that effect to have any potential damaging effect, as it were, on them. So the radiations can have effects on the human body, but not to the degree that people tend to attribute to it. And even the effect takes a really, really long period of time to start to manifest. Just to put that in perspective, if you take a flight from a particular place to another, you would probably absorb more ionizing radiations than living 20 kilometers from a nuclear power plant, actually.
That's right.
Yeah,
That's right.
yeah, and if you take maybe 1 to 9 cigarettes a day, you're at a higher risk, actually, than taking a dose of maybe 3.4 SV from a bomb blast or something. The fears people have around 5G in terms of the radiation effect is not. It's not.
No, that. Thank you for that contribution. That's a really important thing to note. I always say that apart from if you take your pillow and sleep on the tower, under a radio tower, I had a colleague that did a talk on strapping antennas to babies so you could never lose them, and obviously people were horrified. But I think her point was just like we fear what we don't know, and if you fear, that's not the problem. Is if you want to minimize the radiation in your environment, you can do so by doing simple things like not sleeping with your mobile phone next to you because of the thermal effects that have and things like that. And if you are sleeping with your mobile phone next to you, and then you shouldn't be worried about and you're fine, and you will be fine. Then the least concern for yourself should be what happens because they've installed a mast that is maybe 200 meters from where you live.
Yeah. Well, thank you both. Well, thank you, Emmanuel, for contributing. I think that was quite positive, and I can see on the chat quite a lot of people appreciate that you contributed with a little bit more. And obviously, thank you so much, Nikkei, for your presentation today. I think we all absolutely loved it, and also for being available to answer some of the questions that were sent in advance and also the questions on the chat. Unfortunately, we couldn't go through all of them because trying to keep with time, and we're running 5 minutes late already. But I think just
I'm quite happy to answer those questions. So what we'll probably do is we'll provide some answers to those questions and share it with everyone that's attended and has asked the questions. And obviously you can contact us through info@afbe.org.uk if you have even more questions after you've received the answers.
Yes, please do. I will be sending the questions that were asked to Nikkei so that she has a chance to answer them. And thank you, everybody, for being part of this webinar today. I, for sure, was very enlightened and I loved it. We have a great schedule of events for you coming up over the next few weeks. Next week, we have the nitty-gritty, a concrete quiz, sorry, for those who love concrete. And for those who don't know concrete very much like me, you can learn about it. That's with Mimi Isabella. That's on the 29th of April, so next Wednesday at the same time. Please join us then. The week after, we'll be hosting 2 events in the week. We'll have on the Wednesday, 6th of April, several coffee breaks. So it's more a relaxing environment to take your mind off of work and the current situation and just chat with like-minded colleagues. So a bit of a networking exercise. We'll have different times, so please check the website and see which time is more convenient for you and join us. Also on the 8th of May, we'll have our very first hosted quiz. So please don't forget to join us for that. You can organize your own team of 4 people via WhatsApp or something. Do keep your social distance and join us on the quiz. That will be hosted again as a webinar. And on the 13th of May, we'll have our first real projects hosted as a webinar, which will be on the COVID-19 and the era of artificial intelligence. That's the 13th of May at 5 p.m. Do check our website regularly to find out about future events and any updates at afbe.org.uk/events. Again, if you have any further questions about the session or about AFBE-UK, please be sure to send us an email. Nikki just mentioned it, but I'll just repeat it as at info@afbe.org.uk. Then find us on social media on the usual places: Twitter, Instagram, LinkedIn, Facebook. All, as you can see on the presentation, you have our how to find us. And please don't forget to leave us a comment, subscribe, join, follow us on social media. As per previous events, we'll be sending feedback forms. These are very important for us so that we keep on improving. So please, if you could take some time and complete them and return to us, we will appreciate it very, very much. Again, thank you so much for joining us today. And I'm looking forward to seeing you all next Wednesday at the same time. And Nikki, thank you.
Thank you.